still going to continue on with the latch stuff you guys have been doing. A lot of you guys have not finished up the locating practice, so there's still going to be time to get that done tonight. Okay. But tonight we're going to start looking at how do we set the machine and tell the machine where the part is. Okay, because, for example, let's say this whole whiteboard was the travel of my machine. Okay, I can put my part on the table, put it in a vise or some sort of fixture. I got to tell the machine basically where the XY0 position is on my part. So commonly you put it on the upper left corner. Okay. And then you would have to make a precision measurement on the machine and measure exactly, like this, I just said, this half of the whiteboard is my machine travel. Here's my machine 0 coordinate, okay, which on the Haas is pretty much exactly where it is. And it's going to be a precision measurement from that machine 0 position to your part. Okay? So when we program our parts, we always program our parts from a common X0, Y0 position, and Z0 being the face of the part. Fixture offsets allow us to shift that coordinate and put fixture parts, vices, wherever we want on the table. Also, fixture offsets allow me to put multiple parts on the table. So I can have a part over here. And this part can have an origin on its upper left corner. And I can program this part as if it's XY0, Z0, and cut that part at the same time I cut this part. Each of them having different coordinate systems. Okay, that's basically what fixture offsets will do. Your common fixture offsets, Haas and Fanuc, are going to be G54 to G59. Okay, that's your 6 standard fixture offsets. You're going to see that in pretty much all machines going back to older Fanuc 6Ms, Jaedicke. Okay. So the way we would identify this, if this was our first part, we probably would say this is our G54, X0, Y0 coordinate. Okay. If I had this part set up, I would maybe call this my G55, X0, Y0 coordinate. Okay. If I had other parts on my table, I can call them G56, G57. So with the devices that we have on the table, the movable jaw is on the bottom of the part, right? So when I do decide to set fixture offsets, I have to consider a couple of things. First of all, I always want to set a fixture offset on a hard position that's never going to move. Okay? So when I set a fixture offset, I always look, in the example of a standard single station Kurt style vise, I'm always going to put it against the hard jaw on the back edge. I'm never going to put it on the front, because this vise can change. Okay? And if I set it to the front, and you would think, okay, so I buy a piece of 2-inch material, what's going to change? Well, the material. When you buy material, for example, any extruded material, aluminum, cold rolled steel, whatever you're getting, that material has a tolerance. And actually, as you measure the width of your material from one end of the bar to the middle of the bar to the end of the bar, and then maybe a bar that came towards a later part of the lot when they made it, it's going to be a bit different. Okay, it's common for a 2-inch piece of extruded aluminum. It's like the tolerance is like plus and minus 20 thousandths. It's a pretty good tolerance. Okay, so what will happen is, if you set up on one part and your origin's on this side, and this is your movable jaw, you're going to put another part in, and your whole part's going to float because of it. Your dimensions and what gets machined on it's going to change. Okay, so the way you can kind of help prevent that is to always set fixture offsets against positions that are never going to move. If you were going to put a vise stop on the table, you'd want a vise stop typically on this side too. That will control the part from shifting this way, and then the same thing here. Put a vise stop on that side. That will bump it up against that every time. You get a little more reliable product. Now, if you had a double station vise, we do have a couple of double station vices here. You would have, let's see, one part here. I'll make parts first. I'll make the vise jaws in green on this one. So on a double station vise, the center vise jaw is your keyed jaw that does not move. Okay? What opens is this jaw. This jaw opens that way. This jaw opens that way. Okay? So on a vise like this, you might want to say, okay, I'm going to make G50. Well, I got 54 U's, 55 U's. This is the same machine. I'm going to say G56 is right here. This will be my G56 as X0, Y0 position. And then I might put my G57 right here. Okay? So as long as my table has room, I can load it up with parts, fixtures. Okay, there's a lot of things I can put on there. Okay? Now, the standard fan-up fixture offsets went G54 to 59. That is only 6 fixture offsets. Okay, what a lot of companies like to do is they like to have some sort of system on their tables where, for example, this is getting kind of primitive, but on their table they might have 3 pins that are drilled and pressed right into the table of the machine. And then on a pallet rack, they have a series of fixture plates. Nice square plates with different fixtures built on them. Well, they can take those fixture plates off and they can bump them up against those 3 pins. And each of those fixture plates can be pre-located. They can already have the fixture offsets loaded into the offset table of the machine and never have to set their fixture offsets. Okay? That's great, but what if you have more than 6 different parts you ran on that machine? Which is pretty much the case of every company, especially ones that do production work. Well, fixture offsets, the standard G codes give you the 6, but a lot of machine tool manufacturers have utilized the letter E to do the same thing. So E1 is the same exact thing as G54. But the E on a lot of these machines goes all the way to like E100. Okay? So that's one way you can get additional fixture offsets. Some Fanucs have gone to this. Fidel does this. If you guys got Fidels at your shop, you start your program, instead of seeing G54, you'll see an E1. And actually, if you call G54, it looks in the same exact place in the control. Okay? Now this information that we're putting in for the fixture offsets, it's a precision measurement from machine 0 to part 0. It is setup information. You are not going to see this in your NC programs. Okay, because this is going to fluctuate and change depending upon where the vise is locked down on the machine tool. Does that make sense? You will not see these offsets in the NC program. What Haas has done is Haas gives you your standard G54 to G59. Okay? Now, it depends upon the year of your Haas. If you have an older Haas, you had additional fixture offsets that were available. You had G110 all the way to G129. Okay, so basically you got 20 additional fixture offsets with this. I have an older 1996 Haas. This is the additional fixture offsets that we have on my machine. I don't think I've ever used them. Now, we do tool and die work. So tool and die shops, we're typically reinventing the wheel. We got a new setup, new job every single time. We're always having to indicate things. Okay? If you're a production shop, that may not be the case. If you're a production shop, you can think about your tooling and you can make things so you really don't have to indicate things with some sort of common system. Some people, you should move your vices around periodically, but some people like to put their vices there and never move them. Never. And they put everything in there on master cam and surf cam. They set one G54 and everything is on the cam system. And they just always program with that. That's fine. That has pluses and minuses. It has some pluses in that you could get things going very quickly in your machine. It's got some minuses in that you're always machining on certain parts of the ball screw. You're wearing out the machine in just a certain area. Maybe if you did that and you move the vices every 3 months or so, that might be a good idea. Also, when you leave your vices locked down at the table for long periods of time, you get dissimilar rust and corrosion going on under your vices. You get all sorts of issues like that. So it is kind of good to move things around. Anyway, newer hosses also support the same system, but they changed it around a little bit. They use G154. That's what all of our hosses have this. In G154, they used a P for the modifier. And so P1 goes all the way to, on a standard Haas, P100. Okay? And what they've done to make sure that people like me that have a 1996 Haas, if you look on the table, and you'll see it when we get out there in the lab, they have in parentheses that G154 P1 is equal to G110. They share the same exact thing, same exact space. So my old program, if I had used my G110, would still run here in that same exact position, but it would use the G154 P1 position. Okay. G111 would be the P2. The Hosses even have the ability, by changing a setting, if you had a whole bunch of fixtures, and some shops are running multiple parts. They're sharing the same parts on the machine. You flip a switch on the Haas and you can change that P100 to P200. So basically you would have the ability to have 206 different fixture offset positions. Okay? I don't know of anybody that's ever used that many, but again, I'm more in tool and die work. If you're doing production work, there may be some shops out there that have pallet racks full of fixtures. You can pull them down and automatically just run them if they preset everything. Okay. All right, so we're going to be working with some fixture offsets out there today. Where you see the fixture offsets in an NC program. Let's see, I'll just start writing a little bit of a program. So when I write an NC program, and I always start off with a percentage sign on just basic program writing. If you're writing a program off the machine, and you're putting it on a piece of computer, you have to have this percentage sign because this is a communication parameter to the machine that tells it to open the communication port. Okay? The first thing that we have to see on a Haas, a Fanuc style program, is the letter O. This is the only place you're going to use the letter O, with the exception of a comment. Okay? Where you're just typing in something. You should not see an O anywhere else in your NC program. This has to be followed by a program number. So let's say I'll just call it 110. The program number can be 4 digits. It can be up to 5 digits. 4 digits is the most common, yes.
And is actual differentiation between 0 and O?
Yes, there is.
Okay.
Yep. Try to put a 0 there, and you will alarm out. Because that's how it stores.
O.
Yeah, that's how it stores it in the program library. It looks for that O, looks for the number, and that's how it stores it. And all Fanuc and all Haas machines will do this. Okay? So that has to be a 0. I don't know it looks the same, but that has to be a 0. All right, so I'll just type in there. I typically will put the program name here. Fixture offsets. If I'm writing a program, I write the whole thing out. The name of the program, the extension. If it's a .text file, I write .text, .nc, .ncc, whatever it is. Okay, I'll put it right there. All right. So it has to see O first. Cannot see a sequence number. Cannot see N. If you put it in there, you just blocked out the ability for the system to see the O. Only here can you start doing sequence numbers. Okay? The first thing we normally put in an NC program is what's known as a safety block. And it doesn't make anybody safe. But what it's really doing is it's setting the machine up into known modal position. So G90, we're telling the machine that it's in the absolute mode. If we want it absolute, if we want it incremental, we put that right there. Okay? We might say, here's some additional codes we haven't really talked about much yet. G80. G80 is a command that cancels can cycles. Okay, I want to turn off can cycles. Make sure nothing is active when I run my program. I might put a G40 in. This cancels tool cutter compensation. If this is somehow accidentally turned on, this will cause you all sorts of grief when you're running your parts. This just turns it off. Okay? If you did a lot of work at inch and metric, it would probably pay to put the inch G code up there, G20. That way, if for some reason someone had a metric program and loaded it in the machine, is not going to accidentally run it, which could be a problem. Because a move of what is supposed to be about 4 inches, metric, right? 100 millimeters, doesn't go too well in the inch mode. Okay, you better hope you don't got nothing mounted on the end of your table, because it's going to try to go through it if it's a rapid command. It's going to take it as 100 inches, and 100 millimeters is just a little bit less than 4 inches. Okay, so you don't want that to run. And then also very commonly you see in this is what's called, this is a set the work plane. We're setting the work plane to the XY plane. Okay, which kind of seems redundant maybe, but at the same time, I can switch my work plane to G18 and G19 if I want to do an arc going up and down. You can do that in manual programming. People hardly ever do that anymore, versus doing an arc on the flat plane. Okay? With Mastercam, SurfCam, all your cam systems out there, people rarely ever manually program and switch the work plane. It's like hardly ever done. But if it is done, it totally jacks up the machine. It's like if you accidentally have it set to G18 and 19, it's almost guaranteed next time you press cycle start, you will crash. Okay, so this just guarantees that we are in the XY plane. Okay? Something else to know about safety blocks is that some machines will only read 3 G codes at a time. You can put 5 or 6 on there, but it will only read 3. Which 3? First 3? Well, maybe, I don't know. Well, depends upon the machine. I wouldn't gamble on that one. Most of your modern machines will take up to 6 G codes on a line, as long as they don't conflict with each other. Some machines take 4. You know, the newer electronics, newer machines, newer controls are a little more flexible. Anyway, so I got 5 up there. That's more than is needed. The next thing you see in an NC program typically is one of the very first things people will do is change a tool. And I would always recommend this. You always want to make sure you get the tool you want in the spindle. M6T1. And then I always put a comment, whatever my tool is. If it's a 0.5 diameter by 90 NC spot drill. I even put the material. I'm very descriptive about my tools. Okay? Because if something breaks on the night shift and I'm not there, I want someone to be able to look in the program, find the right tool, replace it, and keep going. Okay? Don't want any calls.
And that's just listed on the line like that in the...
Yes. When it's in open parenthesis and closed parenthesis, this is strictly a comment.
Okay.
Okay?
It doesn't pay attention to it.
It's not pay attention to it. Correct.
It has to be uppercase.
All right, so after we do a tool change, the very, very first thing on mill, get that spindle on. Okay? So I'm just going to say M3 S2500 in my little example right here. To get the number, you would have to do cutting speed times 3.82 divided by diameter, get your RPM if you're going to be scientific about it. Okay? But you should. Especially with a lot of exotic materials we got, it's important to get the right speed and feed. Spindle is on, the very next line. So we're up in the air, okay? This is the point, if we want to go to that first vise I have drawn there, we want to position it now, up in the air, while I have the most clearance from the tip of my tool in the part. So this is where I'm going to call fixture offset. Now we've already got G90 modal, we don't have a G0 up. I'll say G0, we're in the G90 mode, G54. If I was going to a hole position, let's say I was going to do a hole. I have 2 holes to do right there. I'm just going to call it 1 inch over and 1 inch down. Relative to that G54. I would say G0, G54, X1 point, X, or Y minus 1 point, This is a really good time to turn on my flood coolant. I will never put a Z on this line. It's going to be a rapid anyway. You don't want to rapid and bring a Z in here right now. You want to strictly position well above the part. Get yourself over that first hole. Go into X1 and Y1. Decimal points are very important because if I'm going to spot drill a hole, where am I spot drilling my hole now? There. You want to spot drill a hole right there? Do I have a hole drawn right there? No, I got the little axis indicator where 0 is. Remember how the FANUC machines interpret? Haas will do the same thing. If you don't put a decimal point, you just put in x of 0.0001, y minus 0.0001. Okay? Haas and FANUC, Haas is fully FANUC compatible. You have to have the decimal points here. So, that's where you're going to see your fixture offsets. If I wanted to do the same exact hole on this part, I could just cut and paste the same exact program and change one thing. And I'll go to that part. 55. If I want to go to this part and do the same exact hole, I can do it. G57. But what if I want to go to that part?
56.
Not going to work so well. I'm going to put a hole right through my solid vice jaw or something like that. Okay, I'm not going to make the boss happy. Okay, so if I do have double vices, I do got to have some concerns of my fixturing because I am going to be moving things around a bit. Anyway, so I couldn't do 56 there in that case. So again, we don't, anything that is the precision measurement of machine 0 to part 0, you're not going to see that anywhere within your NC program. And you wouldn't want to, because that's going to change with every setup of the machine. That's operator setup information. Once we get those measurements, and we're going to use the machine to make a precision measurement from machine 0 to the exact position where your program 0 is, your part 0, and we're going to enter those coordinates into the machine. We could even, if we had a setup, you could set up calipers and inspection measuring tools. You could even measure it that way. It would not be practical. Okay, because the machines have the servo motors, they count out their displays. You can always use the machine to make that measure, and that's always the most precise way to do it. Okay? Anyway, so that's what we're going to be doing today. We're going to be doing the fixture offset assignment, and this is what your fixture offset assignment is going to kind of look like. I got a series of blocks out there in the lab. Okay? And on these blocks, you're going to be setting 5 fixture offsets. This is a really important thing to master. Setting fixture offsets, if you don't get this right, you will just scrap a whole bunch of material. Okay? So, on this upper left corner, we're going to set a G54 position, X0, Y0. On this upper right corner, we're going to set a G55 position. Okay? On this lower right corner, we're going to set G56. And on this position, set G57. And right in the middle of this hole, we're going to set G58. Okay? And this is one of those assignments, kind of like the Visalign. I really need to see it. This is a really crucial thing. Before I sign you off on this, I need to physically see it on the machine. So the way you're going to hand this in, you're going to take that pen's about dead. Take a notebook sheet of paper. And you're going to do 2 Haas's. And really the Haas's, we're being repetitive, but you know, this is something you need to repeat. I'm going to have you guys do it this week. I want you to do it next week. You'll be doing it on your project, setting 1 single fixture offset. But the more of these you can do, the better. Your name. So Haas number 1, X, Y coordinates, you're going to have G54, G55, G56, 7, G58. You're going to indicate the corners and you're going to record the positions. You might want to indicate the corners and not recording yet. And then have me come over, because I'm going to you guys can put an MDI program in the machine as well. But I'm going to show you how to put an MDI program into the machine that will physically move to each corner of the block so we can check it. Okay? Then once I see that you have it there, just like the startups, I'm just going to take my initials and put my initials right there. Okay? You're going to do 2 Haas's. So Haas number 1. So just going to select another block. Do it again on Haas number 2. And then you're going to do it on the Herco. Okay, I've been having you guys do the Herco once. Probably a good idea to have you do the Herco twice as well. Herco's not quite as user-friendly as the Haas. Once you get used to the Herco, it's fine. I mean, you'll set them up just as quick as the Haas, but the learning curve is a little bit longer, jumping through the menus. That position operator display that you guys are using on the Haas for the locating practice, that's extremely handy to be able to zero a display, and then that way the Herco doesn't have that. Okay, so that's going to slow down a little bit. Again, once you get used to a Herco, they're fine, but it just takes a little more time to get used to, and it doesn't have that real handy position operator. So anyway, so after you guys set them, I'm going to come by and check it out, okay? You're welcome to put an MDI program in yourself and try it. I'll come by and do that when I check it. Once I see that it's there, I'm going to just put my initials on it. Once you get 3 machines completed, hand it in, and that's what this fixture offset assignment is.